Thanks. My name is James. And I work for a company called Wyman. Um, and I'd like to talk about this, which is the last year or so of my life. Um, I'm, I'll introduce myself as a software engineer. I've done lots of stuff, but that's where I've landed. Um, but I work for Wyman's a strategy consulting company. I've ended up there kind of by accident, but they need software engineers occasionally because they do some of that. So the technology here isn't actually groundbreaking. I mean, it's not a research topic, um, but it's how I actually, in a business environment, got some green software to actually be there. And I'll try and be quick so that you can ask questions or tell me I'm wrong. That's the software. It's not important. It does finance stuff. It does big data, which is stuff that doesn't fit on one machine. So that graph has stuff behind it that takes a while to process, and there's lots of it. When you build something like this, you have the technology, and then you have all the other stuff around it. So we have data scientists too, who want to do ad hoc analysis and build more models. And we have web stack developers who want things a certain way. And long-term support, they're going to ask questions about, what do I do if you fall under a bus? Project management want to know stuff. Business management want to know how much it costs. Customers want it to work. So there are lots of processes, requirements, and illities like reliability and scalability and sustainability, perhaps. In all my years, I've never heard low carbon or sustainability come up as something, or at least that lasted on the list longer than a week. And that's, I mean, people care about this. The word has gotten out. People may not realize the scale of the problem. They may not agree with the solutions, but they know there is a problem. But they're busy. They've got a job, they've got families. And if you give them extra work, they will be angry. And at the moment, I'm building finance software. We could put a label saying this is green, and that might be some bonus points somewhere, but it doesn't drive the business. There may be legislation in future. People keep on telling me, the legislation will come and that'll fix that, or the price on carbon will come and that'll fix that. I hope so. I have not yet seen it. So I was in the lucky position that I got to say how we do this. So I gave them good infrastructure. Infrastructure is what we have. So we have this building. It's a nice building. We're here because this building's here and it's provided and we can use it. If this was an awful building, we'd still be here. If it was cold, we'd have horrible bar heaters using lots of electricity to heat it, because infrastructure stays around for generations and you adapt and you use it. So if you get the choice of putting in new infrastructure, choose wisely. And wisely is electric and some signal of CO2 and stretchy, I'm going to say, is my three things. Which means electricity can be a renewable. And it's really efficient, and it doesn't really, I mean, we're going to use electricity because it's data centers, but if you're in air transport, you've got a problem. This is why heat pumps are such a good thing. Measurable, we need some measure for CO2. Ideally, it catches attention, so money, and lowish latency, so we can do things with it. And we've been talking about this all the time. We're talking about demand response and scaling to signals that sort of capture the intermittency of renewables and things like that. But we want some feedback mechanism that allows us to drive the process of getting things low carbon. And stretchy, that's the best picture I could come up with. We want to be able to use infrastructure that the CO2 usage scales with the load. And then if we've got a data center, our load can go up and down, someone else's load can go up and down. Overall, the data center load hopefully remains high, so we amortize the embodied carbon of the data center and things like that. And there are some things like, if you've got an old VM and you move that over to the data center, and it's just in this huge instance, and it was an old program that ran once at 100% load for an hour and then at 0% load for 23 hours. That's going to be using a bunch of data center that doesn't need to. If you can re-architect that, that would be better. or just switch things off that you aren't using. So Anne talked about that. The light switch ops was the Holly Cummings, I think, came up with that term. Just switching stuff off that you're not using. This scaling needs software support, which I will talk about a little bit, maybe. This is what we did. I gave them that infrastructure. It was a public cloud. It was electric. We put it in Ireland. I had some choice. I picked the one in that AWS said was used green electricity, or so it claims, because Ireland's carbon grid intensity isn't great. So I don't know why it's green electricity. They do stuff with RECs and things, so you can have that discussion. It is measurable in that their billing information is really good and timely and solid. And we assume that the billing information sort of relates to the carbon usage. We tried to get actual carbon data out of Amazon. It didn't work for us. Like, it just said 0. It wouldn't work anyway because they settle it on a 3-month time lag. So because they do all this carbon accounting and electricity market stuff. We tried using the carbon cloud footprint tool, and we did actually get a graph of carbon usage, but that was based on the billing data, which is actually the way Google Cloud does it, I think. Anyway, I'll talk about that later. And Stretchy, the software support needs to support this. So we use PySpark. Spark is a big data processing thing. It takes your job, generates a big directed acyclic graph of sub parts, and then farms it out on a cluster. The cluster can be auto-scaled. So as your process sort of needs more processing power, it can turn on more servers, and then when it doesn't need them, it can turn them off. And Fargate for Elastic Compute Server, ECS on AWS, also can scale up and down. That was the main thing we did. We just used something that actually does this auto-scaling. We also had this thundering herd problem. Everyone starts batch jobs on the hour. So data centers have this big peak, and they build to match that peak. And then there's sort of like a lot of the time that they don't actually need that. We just started jobs at another time that's not the hour. We would love to see a UI checkbox. I mean, I could build something that looks at the grid intensity and does all that sort of stuff. It's not going to be used unless it's a checkbox in the UI. And I think this is a lot of what's going on, is we know what to do. But when I talk to Databricks about, can you give me some information about the CO2 I'm using, or can you give me a checkbox that allows me to start a job at, depending on, like a bit of hysteresis around the start time or on the grid intensity, they don't know what you're talking about yet. So, it's that message getting out. So what happened? People liked it. It's good stuff. These are good tools. The cost did drive efficiency. We had some people try and train some large models and get told to stop. And the CO2 dashboard was not used in action, but it did spark discussions. One of the discussions was, why do we need that? But that's a discussion. And other discussions were, hey, that's really good, thank you, but we're not using it. So there you go. And so in conclusion, this can be done if you use cost as a lever. Infrastructure is critical, and the scalability and the feedback and so on is important. The hyperscalers need to do the rest, because once you're using their tool, which allows you to split the job up and do the scaling and things, then it's up to them to schedule all this sort of things. So, but actually that re-architecting our entire software stack across the world is enough to be getting on with for a lot of people. Questions? Yeah.
And how have you found closing the feedback loop between telling users that it's expensive to run now in terms of and what they can do about it? Have you had any successes, failures in that?
So yeah, the question is, how do you close the feedback loop between telling someone it's expensive to run and then doing something about it? there were lots of discussions, but it generated heat. Like if I told someone they were using a lot of carbon, they would have told me to go away. And so there were, if a large model run was costing a lot, that raised, that went up the stack, and it was a critical problem. And in one case, that was shelved for a while. Other times, it was just I suppose it was an opportunity for engineers to shine. You could come in and say, "Hey, I just cut our costs by another 10%," and so there was a constant sort of desire to find a few of these and just cut off those low-hanging fruit. Yeah.
Do we have any questions online?
No. Yeah. Yeah. So yeah, on-prem's different because the costs are building the thing and then. Oh yes. So how does this work if you're using on-prem? If you had to go back to on-prem, on-prem is different because the cost is building it, and then you've got as the previous speaker said, there's some ability to scale that up and down, but you can't turn it off as easily. And so this doesn't work quite the same way. Maybe it doesn't work at all. I suppose the advantage of having a big public cloud in that way is that you get to share and everyone gets to fill in these gaps. I have no answer for on-prem yet.
Yeah, I think that's all. This is really great. Yeah, exactly. I think that's really great.
Okay.
Nice things in here. How did you manage to sell them on the idea? Was it benevolent dictatorship in the sense that you had the power, you were the architect, right?
Yeah.
Or did you have
no, I didn't really have to sell it. Like this was at did I have to sell? So the question was, did I have to sell this? Not really. Like choosing the public cloud was obvious. We needed some big data platform. We chose one. I had to, when I set up the clusters, I said, make them auto-scaling. I had to talk people through that a bit, but I didn't get any pushback. Yeah. Okay.
Great, thank you.
Thank you very much.
So next speaker is Catherine West, and no, we have 2 minutes.
Amazing.